So 2.2, the name of this section is called formulas. Now, for the most part, when we're talking a formula in math, for one thing, we're probably talking story problems, but even more than that, we are talking about an equation that has more than one variable. So for example, one formula would be the area equals the length times the width. So if we're looking for the area of that, we've got length times width, and we're given 3 variables. So more than one variable. And we have to, when we're given an equation like this, we have to be given information in the story problem, and that information needs to be such that of the 3 variables, we get 2 numbers to fill in for 2 of the variables so that we're only finding 1 variable. And that's what we're going to start out with. So if I have like the area of a triangle is 1/2 BH, in order to solve one of the, any of these, in order to solve for A, solve for B, solve for H, I have to be given in the problem 2 of the values. So I need to know that B maybe is 2 and H is 3 so that I can solve for A. So remember, the number of equations and the number of variables has to be the same or you can't solve it. So I've got one equation with 3 variables, therefore I can't solve it unless I can whittle this down to only 1 variable. So they have to give me enough information in the story problem so that I only have 1 variable. All right, let's go on here and just get moving with example 1. So we're given the formula. And I'm given 2 variables. So let's see what the problem says. Find y when x is 4. So that means I'm just going to put 4 in here and solve for y. A couple steps to doing this, but it's not too bad. Divide by -4, divide by -4, and my y ends up giving me positive 10 over 4 because 2 negatives, then I reduce. Reducing is very important to me. So, there we go. There's our answer then, given this formula and that x is 4. Now we get into some full-on story problems, like in example 2. They're not just going to say x is 2. You're going to have to get that information out of the story problem. So if we look at example 2, I'm going to let you go ahead and read that. But the formula they give us is x equals 900 minus 300, P as in Paul. So P is, let's just look at it. A store selling art supplies finds that they can sell X sketch pads. So a certain number of sketch pads, we don't know what that X is, at a price of P dollars each. So we don't know how many they're selling. We also don't know how much they're selling them for. That's what we're going to be looking at. According to the formula, which I wrote up there, what price should they charge for each sketch pad if they want to sell 525 pads each week? So if remember, X, they told us, was the number of sketch pads, and P is the price that they were going to sell them at. So what are they looking for? They're looking for how much they need to charge. What price should they charge if they want to sell what? A certain number of pads. So what did they tell you the number of pads was? 525. Well, the number of pads is what X equals. So X equals the number of pads, which is 525. So they told you what X is. And we are left with only 1 variable, and that's what we're looking for, is the price. So we're going to subtract 900, And we're going to get negative 375 equals negative 300p. We're going to divide by 300, negative 300, negative 300. Those go away. Two negatives give me a positive. And we are going to go ahead and reduce that. And we get 1.25. So $1.25 is the price that we're going to sell those pads to. And that will allow us to sell 525. Meaning that because the price is low enough, they're going to sell that many. That's the hope anyway. So example number 3, the dreaded boat problem. So I've got these cool little markers here so I can actually draw my stream. And I have a boat, a bad looking boat. And it's traveling upstream, so the current is going this way. So it's traveling upstream against the current. If the speed of the boat in still water is R, or the rate is another name for speed. That's why they have R there. And the speed of the current, sorry, my printing is really bad on this. This pencil, this eye pencil or whatever it's called is so slippery. So let's see, the speed of the boat. Okay, so we have R is the speed of the boat in still water, C is the speed of the current. The formula for the distance traveled is D equals the speed of the boat minus the speed of the current. Because what's happening is this boat goes in still water at a certain mile an hour. It's going upstream, so therefore it's fighting the current, which is going to slow it down. So actually what happens is the current speed slows the boat down, so we take that current speed away. So instead of it going maybe 6 miles an hour, it's going to go 4 miles an hour because the current is slowing it down. So there's the formula. Times t, which is the time. Distance equals the rate times the time, but because of the current here, we had to subtract it. So that is a very common formula. D equals RT. You will see it over and over and over. All right, so we are looking for C. That's what it's asking us to do. We're trying to find the speed of the current. If D is 52 and R equals 16 and T equals 4 hours. So they gave us 1, 2, 3, 4 variables, and they told us 3 of those 4 so that we're able to find C. So let's plug those numbers in. So we have 52 equals 16 minus C times 4. All right, so we actually have, if we were to rewrite this, well, in fact, let's just divide by 4, the whole thing by 4, and this here by 4. So we end up with 16, 4, 13. Subtract 16 from both sides. Negative 3 equals negative C. C equals 3. So that's the current of the boat. Now there's a couple different ways you could do it. You could have distributed the 4, but that would be more work than it's worth. So speed of the current is 3 miles an hour. So if the boat is going 16, when it's going upstream, it's going to only be 13 miles an hour because the current is slowing it down by 3 miles an hour. All right, let's jump to example 4. So example 4 says if we have something on the ground and we throw it up in the air, eventually it's going to come back down. And when we throw it, it is going to have a certain speed. It's going to speed up a certain amount, and then it's going to slow down. And then what happens is it slows down to the point where gravity pulls it back to the ground. But there is a maximum height that object, that rock or whatever, small puppy, is going to hit a maximum height. And what are we looking for? It says if an object is projected in the air with an initial velocity v, so that's the velocity, the initial velocity, its height h after t seconds is given by this formula. So they're pretty much just giving you the formula. You don't have to understand the velocity, height, vertical velocity, initial vertical velocity, and all this. You just have to write down the formula, and then they'll give you numbers. They want you to find t, so we're looking for that, if v is 64, and this is also going to be t, and h is 48. So when they gave you the initial problem, they gave you h, v, and t. So that means of those three variables, we have to be given two of them. So what did they tell us? They told us that our velocity was 64, and they told us that the height is 48. So what we're going to do here is, given those two numbers, find t. And t is going to tell me how long it took for this object to get up to here. That's what we're looking at in seconds. Okay, so let's kind of clean this up. I'm going to switch these two around just because I like to have my t's on one side. So all I did is just switched them around. You don't have to change the sign, you don't have to do anything, but it keeps everything on the left. I'm also going to switch these two around so that my t squared is first. Right now I'm not really doing anything except trying to make this easier for me. And then I'm going to subtract 48 from both sides so I can get everything on the same side of the equal sign. And I'm going to set it equal to 0. Okay, so next step is, remember what I said about the leading term? If it's negative, we're just going to switch the signs of everything. We actually do it to the right-hand side of the equal sign as well, but because it's 0, it doesn't change anything. So that gives me that. All right, next step is I'm going to divide each side by 16 to get rid of these. So let's just, for another way of saying it, I'm going to factor out the 16, and I'm going to be left with t squared minus 4t plus 3 equals 0. So when I factor out a constant like this, it pretty much just goes away. You don't really need it when this side over here is 0. You can leave it there if you want, but it doesn't really do anything. Factoring that into two binomials, got a t, a 3, and a 1. And both of these are negative. So I'm going to say t minus 3 equals 0 from the last lesson, or t minus 1 equals 0. So t equals 3, or t equals 1. Okay, so here's the problem. I have two answers. Which one is right? When I throw this rock up in the air, it's either going to take 3 seconds or 1 second. It's not going to take both. So let's look real quick at what that means. Now, if you remember when I did my initial drawing, I had my ground. I threw this up in the air and it came back down. All right, so let's just kind of look at this for a minute. When this rock is at this height, let's say that this is 40 feet. It's at this height one time, and then as it comes down, it's also that same height as it comes down. So it's going to take a certain amount of time for it to get this height. A little bit more time is going to go until it gets here. So, for instance, when you throw it initially, it's going to take 1 second for it to get to that point. And then it's going to keep going, and when it comes back down and it's at 40 seconds or 40 feet again, it's at 3 seconds. So you threw it from here at 0 seconds. At this point, as 1 second has passed, when it continues up and then starts coming down, when it hits 40 feet again, 3 seconds have passed. So that's why we have two answers, because it's at that height that we're looking for. What was that height again? It was at 48 feet, 2 different times, going up and then coming down. So that's how you can have 2 answers when it comes to a story problem like that. So I'm going to go ahead and close this down and start with 2.2 B as in boy on revenue, middle of page 120.